The James Webb Space Telescope was supposed to confirm everything we thought we knew about the early universe. Instead, it found black holes that are too old to exist. Not unusual, not hard to explain, too old, as in the timeline says they shouldn't be there yet, and they're there anyway. This is the crack in the foundation that nobody expected the most expensive telescope ever built to find. Here's what the telescope showed us. 700 million years after the Big Bang, which sounds like a long time, but on a cosmic scale is barely a warm-up, astronomers found a black hole already 6 million times heavier than our sun, fully formed, sitting there. 6 million suns worth of mass packed into a single object in a universe that had barely just started. That's like finding a 60-year-old oak tree in a field that your neighbor paved over with concrete 5 years ago. The tree is there, the concrete was definitely there, nobody remembers planting anything, and the tree doesn't care that you're confused. The problem isn't that we found a big black hole. The problem is the feeding rate. Black holes grow by pulling in matter. Gas, dust, stars, anything that gets too close. And physics puts a hard speed limit on how fast a black hole can eat. Here's why. When a black hole eats, the falling material gets incredibly hot and releases energy outward. Light, radiation, heat, all pushing back against the stuff still trying to fall in. There's a point where the outward push exactly matches the inward pull. At that point, the black hole can't eat any faster, no matter how much food is available. It's the physics equivalent of a drain that can only handle so much water per second, no matter how high you fill the bathtub. Scientists call this limit the Eddington limit, and it's not negotiable. Push it harder, and the black hole literally blows away its own food supply. Now, run the numbers in plain English. Start with a black hole 10 times heavier than the sun, which is already what you get when a large star collapses. Feed it at the absolute maximum rate, non-stop, from the very first moment the universe existed. Never miss a meal, never slow down. Give it every possible advantage. By the time 700 million years have passed, you still can't reach 6 million solar masses. You're not even close. You fall short by a factor of thousands. It's not a rounding error, it's not a measurement glitch. The math simply doesn't produce the object we're looking at. Want to feel that gap in your gut? Imagine you're trying to fill a swimming pool using a garden hose. Physics tells you exactly how fast that hose can flow. You turn it on the moment the universe begins. You never turn it off. 700 million years later, someone shows you a full pool. Not just full, but overflowing, walls cracked from the pressure, and tells you the hose did it. You watched the hose the entire time. The pool should be a puddle. It isn't. Stop here. Before we go any further, I want you to pick a side right now. Either something is wrong with how we think black holes grow, maybe the feeding speed limit isn't what we think it is, or black holes can eat through some mechanism we haven't identified yet, or something is wrong with how old we think the universe is. Maybe 13.8 billion years is the wrong number, and the universe is actually older, which would give these black holes more time to reach their current size. You have to pick one. Which one are you betting on? Hold that thought, because you're about to find out that you might have been asking the wrong question entirely. 3 explanations currently survive the math, and none of them are comfortable. The first is called primordial black holes. The idea here is brutal in its simplicity. What if some black holes didn't form from collapsing stars at all? In the first fraction of a second after the Big Bang, we're talking less time than it takes your neurons to fire a single signal, the young universe was an almost unimaginably dense, churning chaos. Patches of that chaos may have been so densely packed that they collapsed directly into black holes before any stars, any galaxies, any structure existed at all. These objects would have been born big, not grown big, born big. If that's true, they'd sidestep the feeding problem entirely, because they never needed to eat their way to their current size. They started there. The oak tree wasn't planted, it arrived fully grown, rings already in the wood, bark already scarred, roots already deep. The second explanation is called direct collapse. Imagine a gas cloud the size of a small galaxy. Normally, that cloud fragments into pieces. Each piece collapses into a star. The stars burn and explode, and some of them leave behind black holes. That's the standard path. But under certain conditions in the early universe, conditions that don't exist anymore, a gas cloud could skip the star phase entirely. The whole thing just falls inward at once, skipping every intermediate step, and lands as a single, massive black hole in one violent event. No stars required, no slow feeding required. One catastrophic collapse, one immediately enormous object. It's the difference between a building being constructed floor by floor over 2 years versus the whole structure being poured from a single mold in one afternoon. Except the building in question is 1,000,000 times larger than anything ever constructed, and it happened before the first sunrise this universe ever saw. Think about where we are right now. We build the most powerful space telescope in history specifically to see the earliest moments of the universe clearly for the first time. And it keeps finding things that our best model says can't exist yet. Not occasionally, consistently. Fully formed galaxies, structures that look billions of years old when they should look like toddlers. And here's what that actually means. Every time Webb sends back a new image, there are scientists in conference rooms staring at data that contradicts the theory they've spent their careers defending. Not refining, contradicting. At what point does a theory stop being challenged and start being broken? You've been following the science. You tell me. The third explanation is the one that should make you uncomfortable regardless of which side you picked earlier. What if we've been measuring the age of the universe wrong? The number 13.8 billion years comes from a specific set of measurements: how fast the universe is expanding right now, how the earliest light from after the Big Bang looks, what the ratio of certain types of matter tells us about timing. These measurements agree with each other. Mostly. But mostly is doing a lot of work in that sentence. Some alternative models put the universe at closer to 14.6 billion years, which is almost 1 billion years older. 1 billion extra years sounds like it would solve the problem. It doesn't, not fully. The gap between what the feeding limit allows and what Webb is observing is still enormous, even with an extra billion years. It helps, it doesn't close the case. You'd need to be wrong about the universe's age by several billion years for the math to work out, and that's not a rounding error. That's a different universe entirely. Here's the final piece, and this is where it gets strange. If primordial black holes are real, if black holes formed in the first fraction of a second, before any stars, just from the raw chaos of the early universe, then they're candidates for something physicists have been hunting for decades: dark matter. The invisible mass that seems to make up most of the universe but has never been directly detected. We know it's there because galaxies rotate in ways that only work if there's far more gravity than the visible stars and gas can account for. The numbers only add up if something invisible is contributing mass. Primordial black holes scattered throughout galaxies in enormous numbers, too small to individually detect, would add exactly that kind of invisible mass. The same objects that break the age rule might also solve the biggest unsolved mystery in physics. 2 separate impossibilities, 1 object, 1 answer that nobody planned for. Do you want that to be true? Think carefully before you answer, because wanting something to be true and it actually being true are 2 different things, and the history of science is full of beautiful theories that died on contact with new data. The evidence for primordial black holes is suggestive, not confirmed. The evidence for direct collapse is suggestive, not confirmed. The evidence for a revised universe age is contested, not settled. What Webb has confirmed, without any doubt, without any controversy, is that the objects are there. The timeline says they can't be, the telescope says they are. Physics doesn't get to hold both of those facts simultaneously. One of them has to give. The universe, it turns out, has a filing error. Something ended up in the wrong era, and we only noticed because we finally built an instrument precise enough to read the timestamps. The uncomfortable part isn't that we found an anomaly. Science finds anomalies all the time. The uncomfortable part is that we found this one right at the very beginning, at the very first chapter of cosmic history, which means every conclusion we've built on top of that chapter might need to be reread. More Webb data is coming. More observations, more measurements, more timestamps that either confirm the anomaly or deepen it. The crack is real. The only question left is whether it's a surface scratch or whether it runs all the way through.